Hello, 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 everybody, and welcome back. Root Beer here, looking at question number 9 on the 2016 MMC paper. Circle O is inscribed, as in the diagram, in isosceles triangle ABC, where AB is equal to AC. Circles P, Q, and R are each tangent to two sides of the triangle, and externally to O as shown. The radius of O is 2 units, and the radius of P is 1 unit. Find the radii of the other two circles. Okay, so we'll probably be using circle geometry. I notice I mentioned tangents, so I'm thinking connect up radii to tangent points, and we're going to get some right angles, and that's a great way to start this one off. So we'll draw our picture, draw it fairly big, and I probably should have put the circles in first. Yes, that is exactly what I should have done. We'll draw the circles and draw the triangle around it. You would think after so many of these math videos I would learn always draw circles first, and yet for some reason I don't. Ugh, this is atrocious. My kingdom for a circle-making device. And it doesn't have to be super exact. I just want everything touching the right way. Okay, the big circles are done, and now we can just sort of add in the little circles. Much easier to add in those. Now, a symmetry argument would tell me that the radii of those circles are equal. Anyway, let's connect up. Get right angles there, and these are all length 1. We have the big circle. These are all radius 2. And I spent so much time drawing the picture, I forgot what they asked me for. Find the radii of circles Q and R. All right. So, it's going to be the same radius, as I say. Put right angles there and there. More 2's here. Alright, so I'll probably start off by saying by symmetry. And you could even say by symmetry along the vertical axis or vertical halfway point. We see Q and R have the same radius. Call it little r. So we have these little r's here. Okay. And this is P, Q, no, sorry, this is O. This one down here is Q, and this is R. Okay. What are we to do? Well, I think perhaps there's some right angle triangles to be found. And I think with a 2 and a 1, we'll probably get something like 30, 60, 90 triangle somewhere. But note if I drop these yellow perpendiculars here, not only do I make right angle triangles here with got a length of 1 as well, but I also get these rectangles. So this length is this length, this length is this length, so this is 1, this is 1. We've got a 1 to something to 3 triangle. Okay. I don't know if this is going to help me, because I mean it's kind of far away from Q down here, but there's no reason we can't do the same thing down here. But it won't, I guess it won't match up to the same place exactly. So there'll be a copy of R here. So I guess 2 minus R, which is this length here, squared, plus whatever the heck this is, we'll call it x squared, is equal to 2 plus R, all squared. So that's true. We also have 2 minus 1, 1 squared, plus I'll call this y, plus y squared is 2 plus 1, or 3 squared. So y is just going to be the square root of 8. This is just root 8, or 2 root 2. No idea exactly how to get x at this moment. But if we take a look here, we can drop the same sort of thing. We get an R here. And so once again, it's going to be the same length x here. Interesting. Very interesting. And that splits it, this isosceles triangle, halfway. Don't know if that's going to help. But we also have similar triangles here. So this angle is the same as this angle. And together with this angle coming from the 1 root 8, 3 triangle, we get a full 180 degrees. So, I suppose I could point out that, call this angle alpha and this angle, these two angles beta. Alpha plus 2 beta has got to be equal to 180 degrees. Alpha is the arc sine of 1, or no, arc cos of 1 over 3, which is never really a nice number to work with. So beta is going to be 180 minus arc cos 1 over 3 all over 2. Or maybe I'll just say 180 minus alpha all over 2. But then 2 minus r is equal to 2 plus r cos beta. The fact that we've got 1/3 there might help us out a bit. This is coming from another right angle triangle. Beta is the angle in between, so hypotenuse times cosine of the angle gives us the adjacent. Alright, so 2 minus r is 2 plus r cos 180 minus alpha over 2. And do I remember half angle formulas? Trying to remember my half angle formulas. It's a part of the trig that I probably should know. I know double angle formulas. Cos of 2 theta is cos of theta squared minus sine squared theta. Now, can I rearrange this and just talk about... Yeah, so if I just want cos theta, I can change this to... So minus sine theta is the same as another cos theta, or cos squared theta minus 1. So that's 2 cos squared thetas minus 1. And now I can rearrange, get cos squared theta all on its own. Square root that. Alright, so this is 2 plus r times the square root of cos 180 minus alpha plus 1 all over 2. Get rid of our derivation there. But cos of 180 minus an angle is just negative of that cosine, and we know cos alpha. I will write this as a second step. So this is just negative cos alpha plus 1 all over 2. And square root of negative 1/3 plus 1 all over 2. So 2 plus r, and then this is going to be 2 over 3 over 2, so square root of 1 over 3. So this is 2 plus r over root 3, and now I can rearrange. So 2 root 3 minus root 3r is equal to 2 plus r. Rearrange some things, we'll get 2 root 3 minus 2 is r plus root 3r. And we'll get 2 root 3 minus 1. We'll just flip over to the other page. Two root 3 minus 1 is equal to 1 plus root 3 times r. Well, we'll divide by 1 plus root 3 on both sides. And now we have an expression for r. I'm going to rationalize the denominator really quickly. 2 root 3 minus 1, root 3 minus 1, all over root 3 plus 1, times root 3 minus 1 is equal to r. But of course on the bottom that becomes 3 minus 1, we'll get 2. And root 3 squared minus 2 root 3 plus 1. So that's 2, that's 2. So I'll get 3 minus 2 root 3 plus 1 is equal to r, or really r is 4 minus 2 root 3. Okay. Does this make sense? In the picture, r is very much a smaller radius than 1, just based on their picture. And 4 minus 2, well, root 3 is about 1.7, so it's about 4 minus 3.4. So it should be about 0.6. Yeah, that makes sense. I'm sure there was probably another way to get this one, but I enjoyed the creating of those rectangles. I think I probably needed a bit more explanation of the trig I was specifically using. For example, I would go back. If I were writing this up nice and neat, I would go back. Go back. There we go. And probably call this something like A and B. C and D, and maybe call this E. We only need 1/2 of the triangle here. But definitely calling these points something, and F, G is that intersection point, H is that point. That would definitely make it easier for me to explain, I'm making this length, and we actually don't need Y here. We just need the alpha, the 1, and the 3 here to get the angle. So you can get rid of that statement as well. But it all just became sort of trig. In fact, we don't even need x, so we don't need that either. We really just needed these angles. That's all. That's actually a little slicker than I thought. So I started off not doing it quite the right way, but, well, certainly not the right way for how I eventually did it. But, yeah, there we go. So r is 4 minus 2 root 3. Not a bad question. I will see you guys in the next video for question number 10.